Okay, so picking up where I left off, I'm going to go fairly quickly through this question because I'm just conscious that the time is ticking on, and it's a bonding and structure question, so it's not super duper complicated. It's mainly knowledge. Okay, not to underestimate knowledge, but it's not problem solving exactly. So bromine. Let's have a look. Let's turn this on. Br2. Molecular. That'll be worth a mark. Or simple molecular. I guess we should probably say that. Simple molecular. Okay. Relatively weak. Van der Waals forces. Okay. Take less energy to overcome. Okay. Because it's asking to basically compare bromine and magnesium. So that's probably worth 2 marks if I had to guess. Maybe 3 depending on how the mark scheme's structured. Magnesium, metallic lattice, because it's a pure metal. Okay, so that's probably worth a mark. Comparatively stronger electrostatic forces of attraction between the positive metal ions and the delocalized electrons. Again, I'm going to kind of skip over this a little bit because it's all sort of stock answers. Stronger electrostatic forces of attraction between positive metal ions and delocalized electrons, which take more energy to overcome. Again, that's probably worth 4 marks now. There's a little additional suggest question. Why is magnesium a liquid over a much greater temperature range compared to bromine? So that's to do with the fact that the forces in liquid bromine are going to be comparatively weak. So there's almost like a number line here, right? If you imagine, let's say, here's solid bromine, there's bromine liquid, and there's bromine gas. I guess technically it should be Br2 because that's what we're dealing with. So what it's basically saying is, why is this range narrow? If you were to do the comparison with magnesium, which is a solid, right, then you'd probably get a much sort of bigger difference between the solid state and the liquid state. That's essentially what it's asking about. Okay, and so essentially what we're saying is this is to do with the strength of forces of attraction, right? Here, the forces of attraction between liquid molecules of bromine will be weaker than they would be in liquid magnesium. It's a strange question, but that's kind of what it's getting at. Okay, so